हेलो बच्चों, a very good afternoon to all of you. Very good afternoon to all of you. Please join the session. We are going to discuss some PYQs. Through that, we will revise the digital electronic. And in the evening at 7 p.m., there will be another session of digital electronics where we will be discussing the questions, important questions of different topics which are framed by our team. And that is going to help you a lot in upcoming GATE examination. So that session is at 7 p.m. in the evening. Okay. Hello. Please join the session. Please show some energy, guys. We are going to start the session with full energy and we are going to discuss some beautiful questions. Okay. So shall we start? In yesterday's class, we have revised the digital electronics, where we have revised majorly the starting three chapters. The first one is the basics of theorems and basics of logic gates. That chapter was very, very important. And then again we have discussed one of the most important chapter, combinational circuit, where we discussed the important topics like K-map, mux, full adder, half adder, comparator circuit, and so on. And then we have discussed the third chapter, that is sequential circuit, and where we discussed about the counters, about the flip-flop, about their characteristic equation, about their excitation table, and then synchronous counter, asynchronous counter, working of ring counter, Johnson counter, and a mod number, how to find out the frequency output and all that. Okay, so these topics are very, very important for your upcoming GATE examination. Okay, so we are going to discuss in next 2 hours to 2.5 hours. We are going to discuss some beautiful questions which are already asked in GATE examination, like in CS branch, in EE branch, or ECE branch, or IN branch. Okay, so let us start. So the first question is this one, which is asked in GATE examination 2021 CS branch. This is 1 mark question and it is based on the number system. If x and y are 2 decimal digits and the relation is already given, the decimal value of x plus y is. Okay, what is the decimal value of x plus y is? Okay, hello Omkar beta, hello, है ना? Hello. Okay, so solve this question, okay, quickly. In the evening session, where we are going to discuss some beautiful questions, I'll take some beautiful framed question of mine. I will frame some question and we'll discuss in the evening session, which is at 7 p.m. at main channel of GATE wala EEC. Okay, tell me the answer of this question, please. Everybody, please answer. Good afternoon, bachcho. Okay, so what is the answer of x plus y? Please tell me the answer. What is the answer? So these two numbers are equal. So whenever the basic principle of solving a question related to number system is, if the relation is given, always convert the numbers into equivalent decimal numbers, because you can solve any equation mentioning in decimal number system. So always try to convert a given number system into decimal number system, you will be very comfortable in solving that equation very easily. Okay, so let us convert the relation into decimal equivalent, and then we will be able to find out the value of x and y, and we need to find out the value of x plus y. Whenever nothing is mentioned, always try to find out the answer in decimal, in the decimal number system. Okay, so expand it. It is 2 to the power, it is 2 to the power 0, it is 2 to the power minus 1, 2 to the power minus 2, 2 to the power minus 3, 2 to the power minus 4. Okay, now 2 to the power minus 1 is into 1, that is 1 by 2 into 1, plus 2 to the power minus 2, 1 by 4 into 1, plus 2 to the power minus 3 into 0, plus 2 to the power minus 4, that is 16 into 1, is going to be equal to, this is 10 to the power 0, if base is 10, this is 10 to the power minus 1, 10 to the power minus 2, 10 to the power minus 3, 10 to the power minus 4. Okay, so this is 8 into 10 to the power minus 1, that is 0.8, plus 10 to the power minus 2. Okay, so this is x point, okay, this is 10 to the power minus 2, that is 0.01 x, plus this is 0.001 into y, plus 0.0001 into 5. Okay, you need to find out the value of, x and y. Basically, we don't need this relation. Actually, we are directly converting this into decimal, so we'll directly compare the corresponding positions. We don't need to write this equation at all, because this number is directly given in decimal, so the decimal equivalent of this number will compare the corresponding bits. Okay, so this is 1.5 is 0.5, 1 by 4 is 0.25, 1 by 8 is, this is 0, 1 by 16 is 0.25 divided by 4, so this is 0.25 divided by 4. What is 0.25 divided by 4? Let us find out the answer of this. Directly we will compare and find out the answer. We don't need to write out this relation, okay, unnecessarily, because this will directly be in decimal format. Okay, so 0.25 divided by 4 is, so this is coming out to be 0.8125 in decimal, and these two numbers are equal. 8 is equal to 8, 5 is equal to 5, so x is equal to 1, y is equal to 2, x plus y is equal to 3, x plus y is equal to 3, x plus y is equal to 3, x plus y is equal to 3. The value of x is 1, y is 2, so x plus y is 3. Okay, ठीक है ओमकार बेटा, कोई बात नहीं. Okay, clear है? Is this clear to everyone? Please answer. So directly we have converted this binary number into equivalent decimal number. This is already in decimal number system, so we have compared both the equations and find out the corresponding bits x and y, and directly we will get the answer 3. Okay, let us move to the next question. This is very beautifully asked question in 2008. One of the very best question. One of the very best question. Okay. Okay. Try to solve this question, and we are going to learn some beautiful insight of number system through this question. Okay. So try to solve this question firstly. I'm giving you 1 to 2 minutes, and then we'll be I'll be solving this question. Okay. Because we have to learn the beautiful concept or insights of the concept, so that if any question related to number system will be asked in upcoming GATE examination, you will be able to solve it quickly and accurately. Okay, try to solve this question. Okay, what is the answer of this question? Very beautifully framed question. Try to answer. Try to answer. What is the answer? So the basic principle of solving any question related to number system, if the base is unknown or the digits are unknown, try to convert the number into equivalent decimal number, and then you will be able to solve it very easily, because you always solve equations in decimal number system by default, and you know that all the operations, how to do it, okay. So always try to solve the question in equivalent decimal number system, okay. This is an hour, okay. So this is MCQ question, obviously only one of the option is correct, what is the answer? What is the answer? Okay, so let me solve it, okay. So firstly, if any number is written in any base, first the number should be correct. First the number should be a valid number. If 120 has to be a valid number, then R must be greater than or equal to 3. And if this number has to be valid number, R must be greater than or equal to 2. Because if base is 3 or higher, then only the digit 2 will be a valid digit. Because if base is R, maximum digit you can utilize is R minus 1. So if R is 3 or higher than 3, then 2, the highest digit appears in the number, will be a valid digit. And if all the digits are valid digit in the R base system, then only the number is valid. So the R must be greater than or equal to 3 for this number should be a valid number, and this is R must be greater than or equal to 2 for number to be a valid number system. Number to be valid number system. Okay. So overall, the conclusion is R must be greater than or equal to 3. So for number, both the numbers which are written in R based system, for them to be valid, R must be greater than or equal to 3. First condition is R must be greater than or equal to 3. And also this relation should also be valid. Apart from R greater than or equal to 3, this relation should also hold good. Then those values which are satisfying, which are greater than or equal to 3 and satisfying this relation which is given, those values will only be correct. Okay. So let us write down the number in decimal, expand it. This is R to the power 2, R to the power 1, R to the power 0. So this is R square plus 2R plus 1. This is equivalent decimal number plus. This is R to the power 1, R to the power 0. So this is R plus 1 in decimal. Now square it. R square plus 2R plus 1 must be equal to R plus 1 whole square, which is, this is now in decimal. So you can directly square it. R square plus 2R plus 1. Now tell me, this equation, this left hand side will always be equal to right hand side for any value of R. For any value of R. Because the square of this is this is coming out to be this, and square of this is also coming out to be this. So this left and right hand side are always equal for any value of R. For these two numbers to be equal. But these numbers to be valid, R must be greater than or equal to 3 also. So any value of R will satisfy this relation, because left and right hand side are always same. Suppose if it comes like this, R square 2R plus 1 is equal to 3R, then this equation is not valid for any value of R. You will take this 3R here, and then you will solve the equation, then you will get some values of R which will be satisfying this relation. This must be equal to this. But here left and right hand side are equal. So if you put any value of R on the left hand side, same value on the right hand side, these two left and right side will always be equal. So this relation is true for any value of R. But R must be greater than or equal to 3 for these two numbers to be valid. So overall what we can conclude, R must be greater than or equal to 3. Because R must be greater than or equal to 3, then these two numbers will be valid, and for all the values of R greater than or equal to 3, this relation, this equal to this, will be satisfied. This relation becomes true. So answer is R greater than or equal to 3. Or we can say that R greater than 2. R greater than 2 means any value greater than 2. Greater than 2 means equal to 3, 4, 5, 6, 7, 8, 9, 10. That is R greater than or equal to 3. So D is the right answer. Okay, clear? Clear? Please tell me. Please tell me. Okay. This is very beautiful question. So firstly, number should be a valid number, and then this relation should be satisfying. And this relation, this equal to this is satisfying for any value of R, and R must be greater than or equal to 3. So these two conditions merged together will result into R greater than or equal to 3. So the answer is D. Not C, not A, not, you know. This is very, very beautiful question. One of the very best question. Okay. Find out the answer of this question. Okay. Find out the answer of this question. One of the very beautifully framed question. What is the answer of this question? Consider a system that uses 5 bits for representing signed numbers, signed integers in 2's complement format. In this system, two integers a and b are represented as this and this. Which one of the following operation will result in either an arithmetic overflow or an arithmetic underflow? Tell me the answer of this question. 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 What is the answer? What is the answer? बताइए. What is the answer? So if you have 5 bits, how to solve these kind of questions, overflow or underflow? If you have 5 bits, the range of the integers that you can represent in 2's complement representation is nothing but 2 to the power n minus 1 minus of 2 to the power n minus 1 minus of 2 की power n minus 1. So 5, this is 2 की power 4. 2 की power 4 minus 1, 2 की power n minus 1 minus 1 plus. So these integers you can represent. The lowest value is this, that is from minus 16 to plus 15. These numbers, these integers you can represent. Only in this range you can represent the integers using 2's complement representation, using 5-bit representation. Now, what is the value of A? A is a positive number because MSB is 0 and 1010 is 10 in decimal. Convert it into decimal. B is the negative number because MSB is 1. Now this is 2 to the power 4, 2 to the power 3, 2 to the power 2, 2 to the power 1, 2 to the power 0. So take MSB, the total weight of the MSB as negative and expand it. So minus 16 into 1 plus 8 into 1. Minus 16 plus 8 into 1 plus 4 into 0 is 0 plus 2 into 1 is 2 plus 0. So this is coming out to be minus 6. Okay. Now, if any of the above operation, any of the given operation results into outside this range, then overflow will occur. If any of the given operation results into a number which is outside this range, outside 15 or outside minus 16, then overflow will occur. Okay. Now, A plus B, what will be A plus B? 10 plus minus 6. This is plus 4. So overflow will occur. No, sir, no overflow is there. A minus B, 10 minus 16, minus 6, that is 16. Overflow will occur? Yes, sir. Because on positive side, we can represent only up to 15. We cannot represent 16 plus 16. We can represent minus 16, but not 15. Okay, so overflow will be there in case of A minus B. B minus A, B is minus 6, minus A is 10, minus 16. Minus 16 we can represent. So overflow will not occur. Hai na? 2 into B, 2 into B is minus 6. This is minus 12. So in decimal you can operate very easily. You don't need to find A plus B and A minus B and B minus A in 2's complement representation and then find out whether overflow is occurring or not. Hai na? That will be a lengthier method. That is also a method, but that is a lengthier method. So this is minus 12. Minus 12 we can represent. Minus 16 to plus 15. Minus 12 will in this range. Minus 16, then minus 15, then minus 14, then minus 13, then minus 12. So this is wrong. So option B is correct. Okay. That's how you can solve this question very, very quickly, very, very easily. Is this clear to everyone? CRC wala clear? Please tell me. Then case of A minus B operation, there will be overflow. Okay. Got it? There will be a overflow. Got it? Option B is correct, not A. Okay, beta? Right. Pooja ho rahi. Okay. The range is wrong, beta. Minus 32 to 31. No. The range is 2 to the power. If there are n bits, Ankit the engineer, correct your. From n bits, total how many combination will be there? 2 की power n. From 5 bits, how many combination will be there? Only maximum 32 number you can represent, beta. In sign number representation, some of the representation are used as a negative number, some of the representations are used as a positive number. Total number you can represent is 32 only. How minus 32 to 31? Minus 32 to 31 is 64 numbers. From 5 bits, how you can represent 64 numbers by common? Use your common sense, beta. है ना? So from n bit, you can represent total 2 to the power n numbers in signed number representation also, 2's complement representation also, unsigned number also, because from n bits you have only 2 to the power n combination total. So you cannot represent more than 2 to the power n numbers. In signed number representation, that combination is treated as negative. MSB bit is 1. In unsigned representation, this is plus 8. But in signed number representation, 2's complement is minus 8. Representation is the same only. You are treating it as negative or positive because you are defining it. So, you can represent from where to where? 2 to the power n minus 1, 2. In case of 2's complement. This is the range. Not 2 ki minus 2 ki power n to minus 2 plus 2 ki power n minus 1. Okay. So, Ankit the engineer, correct your formula, correct your concept. Okay. है ना? तो आपके लिए डंडा लेके आना पड़ेगा, है ना? कुछ भी कर दे रहे हैं. This is one of the very, very beautiful question asked in GATE examination. It's also in CS branch. So the number system questions are very beautifully asked in CS branch. Okay. So the range is minus 16 to plus 15, not minus 32 to 31. If the range is minus 32 to 31, then no option is correct because then no overflow will occur. All the results are in between minus 32 to plus 31. Okay. Ankit the engineer. Okay. Correct your concepts, beta. Here. Tell me the answer of this question. What is the answer of this question? One of the very beautifully framed question. So one of the, if a number is written in binary, let's say a number is 101 in a binary number system. What this number is in decimal equivalent? 2 की power 2 into 1 plus 2 की power 1 into 0 plus 2 की power 0 into 1. If you multiply this number by 2 to the power n, let's say 101. If you multiply this number by 2 to the power n, this number, what will happen? Multiplication of 2 to the power n. Here 2 to the power n plus 2, here 2 to the power n plus 1 into 0 plus here 2 to the power n into 1. How we can write this number? How we can write this number? This number. Suppose this 2 to the power n is nothing but 2. This is nothing but 2. 1, 0, 1, 2. Then this will become 2 to the power 3 into 1 plus 2 to the power 2 into 0 plus 2 to the power 1 into 1. If you will calculate this number, this is 2 to the power 3, 2 to the power 2, 2 to the power 1. You can write 2 to the power 0 into 0 because in binary to decimal conversion 2 to the power 3, then 2 to the power 2, then 2 to the power 1, then 2 to the power 0. So this is 2 to the power 3, this is 1, then this is 1. This is 0, then this is 0. This is 1 and this is 1. This is 0, then this is 0. This is basically this number. If you expand this number, you will get this. If I multiply with 2 to the power 2 into 101, what will happen? Let us take this. This is 2 to the power 4 into 1. This is the original number. And 2 to the power 3 into 1, 0 plus. Then 2 to the power 2 into 1. Now 2 to the power 4, 2 to the power 3, 2 to the power 2. I can write 2 to the power 1 into 0 plus 2 to the power 0 into 0. Because from power is decreasing and goes up to 0. So this is 1, this is 0, this is 1, this is 0, this is 0. So this is the number after multiplication by this. So what is happening? If I will multiply with 2, 1 0 is added on the right side. If I will multiply it by 2 to the power 2, 2 zeros are added in the number. So here what is happening? If I will write P in the binary format, always write in binary format. There is F 1 1 1. There is 8 1 0 0. There is 7 0 1 1 1. Binary. If number is in binary, then only you will add zeros. Okay. B is AB. B is 11 1 0 1 1. B is 11 obviously. Now if I will multiply 8 into P, this is in binary. This is in binary. So if I will assume this to be in binary, 8 into P is nothing but 2 to the power 3 into P. So adding n zeros, if multiplication by 2 to the power n in a binary number system will equivalent to adding n zeros. So what will happen? This will be result into 1 1 1, 1 0 0, then 0 1 1, then 1 0 1 1, and then 3 zeros are added. But the result is only in 16 bits because this is 4 bit, 4 bit, 4 bit, 4 bit. Hexadecimal to binary conversion, if I'll convert this, the result will be in 16 bits. So I have to write this. This is signed number. This is 2's complement represented number. So 8 into P is also 2's complement number. This number is basically in 2's complement representation. This number is basically in 2's complement representation. So I'll have to represent this into 16 bit. And you know that copying MSB to the left of MSB will not change the result in 2's complement representation. If I'll copy the MSB bit n number of times, any number of times to the left of MSB in 2's complement sign number representation, result is not going to change. So what I'll do, this is 4, this is 4, this is 4, this is 4. If I will take this one as MSB, I am copying this 1 time, 2 time, 3 time, will result be changed? No sir, result is not going to change. So I can write this result is equivalent to this. Can I write down this result in 2's complement representation? Because I have taken 16 bit. I have removed these 3 ones because 3 zeros are added, and copying MSB to the left will not change the result. So if I'll remove 3 ones, the result will be of 16 bit. I can remove this one also, because if I'll take this as MSB, then this MSB is copied in the left. I can remove this one also, but I have to go for 16 bits because I have to represent the result in 16 bit. Okay, so I have removed 3 ones which are copied. Okay, now make the group of 4 from the left to right. 4 for binary to hexadecimal conversion. This is 12. 12 is ABC. So this is C. This is 0011. This is 3. This is 1101. This is 13. ABC D. This is D and this is 8. So result is C3D8. C3D8 is the option A is absolutely correct option. Got the answer? Please tell me. Got the answer? Please tell me. Is this clear? सबको क्लियर हो गया अच्छे से? सीआरसी वाला लिख दो भाई. Okay, so multiplying by 2 to the power n to any binary number is equivalent to adding n zeros in the right side, on the right side the number, and then we have applied the property of 2's complement representation, because we have to represent the result in 16 bits. Okay, now try to solve this question. Okay, try to solve this question. Very important question. That was very important question. What is the answer of this question? तो मजा आया पिछले क्वेश्चन को करके? You have learned something or not? है ना? Always try to find out the concept, find out the symmetries, है ना? So in GATE PYQ we have solved so far. You have observed that, you would have observed that, है ना? That the questions are not very lengthy. They are tricky. You have to use your fundamentals. You have to use your you have to use the symmetricities. है ना? You have to use the correlations. If you use that correlations, your answer will be very, very simple. है ना? Will not be that tough. Okay. Two numbers are chosen independently and uniformly at random from the set 1 to 13. From 1 to 13. 1, 2, 3 up to 13. So two numbers are chosen. So how many different groups are possible of the two numbers together? That will be 13C2. 13C2. Out of 13 numbers, choosing any two numbers at a time will result into these much two numbers combination, 13C2. These number of combinations are possible of two numbers chosen from 1 to 13. Because there are total 13 numbers and you are taking two numbers at a time. And you are forming 13 C2 groups. Now, the probability that their 4-bit rounded up to 3 decimal places, 4-bit unsigned binary representation have the same most significant bits. Same most significant bits. Okay. So, in how many combinations, they are asking you, in how many combinations, probability that the two numbers being chosen will have the same most significant bit. Now, write down the number. 1 is 001, 2 is 001, 2 is 0010, and up to 0111. From 1 to 7, MSB bits are 0. And from 8 to 13, 8, 9, 10, 11, 12, 13. 13 is 1, 1, 0, 1. So from 8 to 13, the MSB bit is 1. So how we can choose two numbers having the same MSB? That are the possible combination. Favorable conditions are, if I'll choose two numbers from these 7 numbers, these 1 to 7 numbers, then these two numbers will have same MSB for sure. Or I'll choose two numbers from 8 to 13, which are from 8 to 13, there are 6 numbers. There are 6 numbers. Okay. So if I'll choose two numbers from these 6 numbers, then I will also have the same most significant bit, that is 1. So in these total number of combination, the two numbers being chosen will have the same MSB bit, same most significant bit. And total number of possible combinations of two numbers being chosen is 13C2. So what will be the probability P? That is favorable condition divided by total number of conditions. That is the answer. That is the answer. Okay. What is the 7C2? You can solve this question. What is the 7C2? Factorial 7 upon factorial 5 into factorial 2. So this is 7 into 6 divided by 2. This is factorial 6 upon factorial 4 into factorial 2. That is 6 into 5 divided by 2. This is 13 into 12 divided by 2. Okay. Now, what is the answer? 2 got cancelled out. If you will multiply 2, so this is 7 into 6. This is 12 into 6. Numerator is, because 2 got cancelled out from upper side and lower side. And now, if 6 common, 7 plus 5 is 12 divided by 13 into 12. So 12 is cancelled. 16 by 13 is the answer. Your calculation should be good. Okay. This is 6 by 13. This is nearly 0.5. Okay. So let us solve 5 divided by 13. It is coming out to be 0.384615. So they are asking to find out the answer up to 3 decimal places. So you have to write down the answer up to 3 decimal places. So this, the fourth place is greater than or equal to 5, then you will have to add 1. So this is 0.385 is the right answer. 0.385 is the right answer. Got the answer? Everyone, please say. So this is the question of basically distal plus math. Okay, distal plus math. Now let's move to the next question. We have already solved this question, I guess. Okay, this is now solve this question. What is the answer of this question? Okay, देव बेटा, दिस इज क्लास ऑफ डिजिटल इलेक्ट्रॉनिक ना, डिफरेंशियल रजिस्टर अभी रहन दो, जाके पढ़ लो बेटा, ढूंढ लो कहीं से, पढ़ लो, बुक खोल लो, है ना। ये ईडीसी की क्लास नहीं चल रही है, कहां से बेटा, कैसे दिमाग लेके कहां कहां आ जाते हो भाई। डिजिटल इलेक्ट्रॉनिक का पीवाईक्यू डिस्कशन चल रहा है यहाँ पे यार, हाँ भाई हम ईडीसी पढ़ाने लगे यार, तो कुछ तो कॉमन सेंस यूज कर लिया करो खुद से। मतलब कोई ऐसी क्लास थोड़ा चल रही है कि यार टॉपिक ऑन डिमांड बताओ बेटा क्या पढ़ाना है ना। अभी डिजिटल चल रहा है तो डिजिटल का डिस्कशन होगा कि हाँ ईडीसी, यहाँ सीएस के बच्चे भी हैं, ईसी के भी हैं, डबल ई के बच्चे हैं। डबल ई का बच्चा क्यों पढ़ेगा यार उसको ईडीसी का पार्ट, है ना। थोड़ा सा खुद भी कॉमन सेंस यूज किया करो बेटा। चलो इसका आंसर बताओ। What I have calculated, answer is 6 by 13. I have calculated 5 by 13. Sorry, 6 by 13. It is 0.461. In calci, I have put it 5, है ना. So this is 0.461538. Okay, 6 by 13. So this is up to 3 decimal places. It will be 5 added 1, 0.462. Not, है ना. In calci, I put it 5 divided by 13. That's why 0.384 was coming. 6 by 13. Okay. So everybody is getting the wrong answer. Everybody is getting the wrong answer. 0.58 is wrong answer. 85 by 169 may be the correct option. I don't know. Okay. 0.462 is the right answer. Soumyadeep, it might be the wrong answer. I as per my calculation. Okay. 6 by 13 is the right answer. So this is 0.462 is the right answer. Okay. That was calci mistake. No, solve this question. What is the answer of this question? Now consider the 4 variable function f1, f2, f3 which are expressed in sum of for the following circuit with one AND gate and one XOR gate, the output function. So let us assume this to be f4 and this to be f3. It is already f3. What will be f4? The SOP expression of f4 will be what? The terms which are there in f1 as well as f2, corresponding to that term f1, f2 both will be 1, 1 and 1 into 1, and the output of AND gate will be 1, and those terms will only come in the SOP expression of f4. So the terms which are present in both f1, f2 will only come in the SOP expression of f4. So where is f1, f4 and f2? 0 is present in both the terms? No sir, only here. 1 is missing in both, 2 is present in both, so 2 will be here, because corresponding to term 2, this also 1, this is also 1, and f4 will also be 1. So in SOP expression we take only those terms for which output is 1. Term 3 is missing in one of the functions, so it will be not in SOP expression, it will be rather in PUS expression of f4. 4 is missing in both the cases, 5 is missing in one of the function f1, f2, 6 is missing in one, 7 is missing in both, 8 is present in both, so 8 will be there in AND operation. 9, 10, 11, 12, 13, 14, 13 are missing in f1, so those terms will not be in SOP expression rather than POS. 14 is present in both, so that will be. So in case of AND output, the terms which are there in both the function will only be in the SOP expression of result. Okay. Now f3 is already here. In case of XOR, only those terms will be there in the expression, in SOP expression, which are there in one function but missing in other function. Why? Because if a term is there in F4, corresponding to that F4 will be 1, but if it is missing in F3, then corresponding to that term it will be 0, and 1 XOR 0 will be 1. Or if term is there in F3, corresponding to that term F3 will be 1, but it is missing in F4, that will be F4 will be 0, 0 XOR 1 is 1. So the term which are there in one function and missing in other function, corresponding to those terms XOR produce output 1, and those terms will be there in the SOP expression of XOR. So start with 0. 0 is missing in both, will not be there. 1 is missing in both, will not be there. 2 is missing, 2 is present in both, will not be there. 3 is missing in both, will not be there. 4 is missing in both, will not be there. 5 is missing in both, will not be there. 6 is missing in both, will not be there. 7 is here but missing here, will be there. The term which are there in one function but missing in other will be there in the result of XOR. 8 is missing here but present here, will be there in the expression. 9 is missing in both, will not be there. 10 is missing in both, will not be there. And in SOP expression it will not be there, it will be in PUS expression. 11 is here but missing here, will be there in SOP expression. 12 is missing in both, will not be there. 13 is missing in both, will not be there. 14 is present in both, will not be there. 15 is missing in both, will not be there. So 7, 8, 11 will be there. Option B is correct. Option B is correct. Absolutely right. Everybody got the correct answer. Very, very well done. Okay. Let's move to the next question. It is related to the prime implicant. Find out the prime implicant of this given question. सही है आंसर. What is the answer? Somebody is getting 5, somebody is getting 3, somebody is getting 4. What is all this? 4, 5. Prime implicants. They have asked you to find out the prime implicants, not the essential prime implicants. Out of those prime implicants, some will be essential, some will be non-essential. Okay. So you need to find out the prime implicants. The group which cannot be combined further to form the bigger group are called as prime implicants. W bar X bar, W bar X, W bar WX, WX bar, Y bar Z bar, Y bar Z, YZ, YZ bar. Okay. Now this is term 0, this is 1. Term 1 is not here, term 2 is 1. 3 is not here, 4 is 1. 5 is 1, 6 is 1, 7 is not here, and 10. 8, 9, 10, 11. 8, 9, 10, 11. 10 is here. Okay. So only 3, 4, 6 terms are here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So only these terms are there. Okay. You need to find out the prime. The groups which cannot be combined further are called as prime implicants. Now, so these, what the possibility? You cannot form octet here because there are only 6 ones. For octet you need 8 ones. The best possible group is going to be quad. If quad is not possible, then we will go for pair, and if pair is not possible, we will go for single term. है ना? Okay. अमित बाइंस कितना फास्ट करना है बेटा, है ना? Okay. ठीक है. So this one has a quad option which I have already made, and this, what the option this single one has is, it is having a quad option? No sir, it is having only one option which is pair option, and you have to make this pair. So this already formed. This one has only single option which is a pair, and how it can be formed? It is only one option which is this pair. Apart from these 3 groups, any other possibility is here? No sir, no possibility is here. Can I use the used one and form a group which cannot be combined further? No sir. Which one you can combine to form a group which cannot be combined further? Can you combine these 2 ones to form a group? This group can pair with this group to form a bigger group, quad. So this is not a prime implicant. Apart from these 3, 2 quads and 1 quad and 2 pairs, you cannot form any group which cannot be combined further. So only these 3 are prime implicant, and if you go further to find out, all these 3 prime implicants are essential prime implicants. How someone is getting 4 prime implicants? From where you are getting 4 prime implicants? This group is a prime implicant? No. This pair can be combined with this pair to form a bigger group, a quad. So it cannot be a prime implicant. Prime implicant is an implicant which cannot be, is a group which cannot be combined further. So always the best possible group which you form for the K map are always prime implicants. Then by using the already used one, if we can form any group which cannot be combined further, that is also a prime implicant. But here that possibility is not present. We cannot combine used ones to form a group which cannot be combined further. There is no possibility here. So only 3, 1 quad and 2 pairs, all are prime implicant, and R are essential prime implicant. There are 3 prime implicants. A quad which cannot be combined further, 2 pairs which cannot be combined further to form a bigger group. Only 3. And all these 3 are essential because this quad has these 2 ones which can be covered only by this white prime implicant. This pair has this one which can be covered only by this prime implicant only, and this green prime implicant has this one which can be combined only by this prime implicant, है ना, which can be covered. So essential prime implicants are also 3. All these 3 prime implicants are essential, है ना. How you are getting 4, 6, 5? ओमकार बेटा, how you are getting 4? पास करते हैं तो बेटा तुम रिकॉर्डेड देख लेना 2x की स्पीड में, ठीक है. हम इस क्वेश्चन से रिवीजन करने आए, ठीक है ना. जिनको नहीं आता उनके लिए है सेशन. अगर बेटा आपको ज्यादा आता है तो आप 2x की स्पीड में, जब बाद में 2 घंटे बाद खत्म होगा, वैसे भी 4 बजे सेशन खत्म कर देंगे, है ना. तो आप देख लेना, फिर 7 बजे वाली क्लास में आ जाना. अमित बेटा कल भी आप रिवीजन में थे, है ना, ठीक है. इसका बता दो आंसर. So 3 prime implicants are here and all are essential prime implicant. चौथा ग्रुप जो बनाए हो ओमकार बेटा, देखो कहां से बनाए हो, वो क्या फर्दर कंबाइन नहीं हो पा रहा है, देखो ध्यान से। जबरदस्ती कोई भी ग्रुप मत बना दो ना बेटा, जबरदस्ती बनाने वाला है ना। तो आंसर इज 3, नॉट 4, नॉट 5, नॉट 6. Some of the students got the right answer. Very good. Now tell me the answer of this question. Tell me the answer of this question. Tell me the answer of this question. Sorry. चलो बताओ इसका आंसर। Now they have asked you to find out the essential prime implicant. So for finding out the essential prime implicant, you need to find out all the prime implicants, and then you need to check whether a given prime implicant which you have already formed is essential or not. If at least single one is there which can be covered only by that prime implicant, then that prime implicant is essential. If all the ones of a prime implicant can be covered by other prime implicants also, then that prime implicant will not be an essential one, है ना? So let us form a K map for finding out this essential and non-essential prime implicant. Okay. This is A bar, B bar, A bar, B, A, B, A, B bar, C bar, D bar, C bar, D, C, D and C, D bar. 0, 2, okay, 5, 6 and 7, 8, 9 and 9, 10, okay, 11 है नहीं, 8, 9, 10, 11, 12, 13, 14, 15, 12, 13, 14 and 15. How many prime implicants are there first? Firstly, I am asking you to find out the number of prime implicants here. Everybody, please answer. है ना? If you can find out the number of prime implicants correctly, then believe me, you will always find out you will be able to find out the number of essential prime implicant 100% correctly. So the finding out the number of prime implicants is the most important task. And in that, firstly try to form the best possible group as you find out in solving the K-map question. Then by using overlapped one, if you can form a group which cannot be combined further, that will also be a prime implicant, which will be definitely a redundant prime implicant. Okay. So firstly, corner one is there. So this one has a quad option. Definitely this is a prime implicant because this quad cannot be combined further to form an octet. Can you make an octet from this quad? Because from quad the bigger group is octet. Okay, so this is a prime implicant for sure. This one has only one quad option. This one has only this quad option. It don't have any other option. Okay, so this is also a prime implicant for sure. And now this one has two options. This one has two options. Either it can form this quad, either it can form this quad. If you go for this quad, definitely now the K-map solution will have three quads. This one was having two options. This one is having only one option, corner quad. This one is having only one option, this quad. So these two quads will definitely be there because here a single one is there which has only this option. So these two quads will definitely be there. But this one has two options. This quad option also, this quad option. It will make this quad. Now all the ones are used. So you cannot make this quad if you are solving it for a K-map solution. But This quad is a prime implicant because it cannot be combined to form a bigger group, which is octet. But here you have already find out that this quad is also possible and this quad cannot be combined further to form an octet, because octet is not possible here in any case. Total 8 ones are not there. You cannot find out any octet here. Can you make? If these two ones here, these two ones are there, then you can make octet. These two ones are there, then you can only make octet. So octet is not possible anywhere. So if I can make a quad, it will definitely be a prime implicant, because quad can combine to make further a bigger group octet, then only it will not be a prime implicant. So quad will definitely be a prime implicant because octet is not possible here. So if I can make a quad, it cannot be combined further because octet is not possible. So in prime implicant, used ones are also utilized. So this is also a prime implicant for sure. This is also a prime implicant for sure. So firstly, you need to find out all the best possible group as per the K-map solution. Then try to find out whether I can make a group which can be made out of used ones and which cannot be combined further, then that will also be a prime implicant. Now these 4 prime implicants are possible, because this one is only one option, this one is having only one option, but this one is having 2 options, and these 2 best options will definitely be a prime implicant. Best options are always prime implicant. So this one was having 2 options, this quad option and this quad. So in K-map there are 2 solutions possible. If I can make this group firstly, then I will not make this white group. If I will make this white group firstly, then I will not make this group. So 2 possible solutions are there for this K-map, where 3 quads will be the solution, but there are 4 prime implicants. Okay, now let me check which prime implicant is essential and which is not. Now this corner quad is a prime implicant because it cannot be combined further. Here these two ones will only be covered by this prime implicant. So this is definitely a essential prime implicant. Now I am checking one by one which prime implicant is essential. So this corner one is B bar, D bar, here from D bar, here from B bar, is a essential prime implicant for sure. This pink prime implicant, these 2 ones will be only covered by this pink prime implicant. It cannot be covered by this prime implicant or this white prime implicant or this C green prime implicant. So these 2 ones only can be covered by this prime implicant only. So therefore this is the essential prime implicant. Its value is B and from here D. So BD is also essential prime implicant. Now let's check this horizontal prime implicant AB. There are 4 prime implicants. Okay, AB. This one, this green prime implicant, this one can be covered by this green prime implicant, but also can be covered by this white prime implicant. This one can cover by this pink prime implicant also. This one of this green prime implicant can covered by this pink prime implicant also. This one can be covered by this white prime implicant also. So it is a non-essential prime implicant. It is a prime implicant for sure, but it is non-essential. Now the 4th prime implicant, let's check for this. This is A and this is D bar, AD bar. It is also prime implicant. From here A and from here D bar. Now this one of this white prime implicant can be covered by this C green prime implicant. This one of this white prime implicant can be covered by this green prime implicant, corner prime implicant. This one of this white prime implicant can be covered by this C green prime implicant. This one of this prime implicant can be also covered by this green prime implicant. So all the ones of this prime implicant can covered by other prime implicants also. So this is also a non-essential prime implicant. Okay. So the essential are BD and B bar, D bar. While in K-map solution, what are the K-map solution? Essential will definitely be there. One of the, if I'll make AB first, then I will not make this AD bar group. And if I'll make AD bar first, then I'll not make this group AB. So solution of K-map is this. Either this solution 3 quads, either this solution 3 quads. But the essential prime implicants are only the option A. बेटा बीच बीच में ऐड क्यों आ रहा है, वो जाके पूछो किससे, वो जाके पूछना पड़ेगा यूट्यूब वालों से। बेटा यूट्यूब देख रहे हो तो फ्री में ऐड वाला तो देखोगे ना बेटा, फ्री में देखोगे तो ऐड वाला होगा ही ना। यूट्यूब का सब्सक्रिप्शन ले लो, ऐड आना बंद हो जाएगा बेटा तुम्हारे में, ठीक है। तुम ऐसी बातें कर रहे हो बेटा, इंजीनियर हो, पढ़े लिखे लोगों की तरह बात करा करो। एनएस जी, आज तक तुम्हें यही नहीं पता चला। यूट्यूब का फ्री वर्जन यूज करोगे तो भाई ऐड दिखाएंगे, तो तुमको फ्री में सर्विस दे रहे हैं, कहीं से तो कमाएंगे, नहीं तो पेड वर्जन ले लो, उनका ऐड नहीं दिखेंगे बेटा, है ना। जब जॉब करने लगना, पैसे कमाने लगना, पेड वर्जन लेना, कोई नहीं दिखेगा। अभी स्टूडेंट हो, ऐड से काम चमा लो, और एक दो ऐड देख के क्या हो जा रहा है बेटा, कितना टाइम वेस्ट हो जा रहा है। ऐसे रो रहे हो जैसे लग रहा है पता नहीं दुनिया, लोग पता नहीं कितने सालों से ऐड के साथ देखे जा रहे हैं, सब्सक्रिप्शन कोई नहीं लेता है ना, ठीक है। ऐसी बातें मत किया करो बेटा, तुम लोग कभी कभी ऐसी बातें करते हो, लगता ही नहीं तुम लोग इंजीनियरिंग कर रहे हो कि पता नहीं क्या कर रहे हो, है ना। एकदम गधों टाइप की बात कर देते हो रह रह के बीच बीच में। The output Y of a 2-bit comparator is logic 1 whenever the 2-bit input A is greater than 2-bit input B. The number of combination for which the output is logic 1 is, बताइए जल्दी से। आउटपुट इज लॉजिक 1 मतलब इन हाउ मेनी कॉम्बिनेशन A greater than B is true, तभी तो आउटपुट 1 आएगा। वही पूछा, क्वेश्चन को घुमा के पूछ दिया। अभी यही पूछ देता द नंबर ऑफ कॉम्बिनेशन फॉर विच द आउटपुट इज लॉजिक 0, तो आपको बताना है कितने कॉम्बिनेशन में वो फॉल्स होगा, पीओएस वाला बताना है। हम जो n1 n2 n3 कैलकुलेट करते थे वो एसओपी एक्सप्रेशन के नंबर ऑफ टर्म्स होते थे, और उतने कॉम्बिनेशन के लिए आउटपुट 1 होता है ना। वीडियो देखते वक्त पूरे टाइम थोड़ा आएगा बेटा, है ना, वो तो आएगा यार बीच बीच में यार। अब इस बात पे फालतू की बहस ना करो ना चैट में यार, पढ़ाई लिखाई करनी तो करो बेटा, ऐड आ रहा है तो जाओ कहीं और देखो, ठीक है ना। फालतू की यार नौटंकी फैलाने के आ जाते हो यार फालतू में, है ना। ऐड आ रहा है यार तो मैं ऐड बंद करवा दूंगा क्या तुम्हारा, फालतू के कमेंट करने आते हो यार, पढ़ना लिखना नहीं है, बस फालतू कमेंट करना, ये आ रहा है सर, वो आ रहा है, गधों टाइप से। पढ़ाई लिखाई किया करो बेटा, है ना, गधों वाले कमेंट करने मत आया करो फालतू में। उस पर फिर लगोगे वकालत बैठाने, वहीं पे जजमेंट करने, जिरह चल रही है, डिस्कशन कर रहे हो इस फालतू सी बात पे, है ना। बेटा हम इसका सोल्यूशन देने नहीं बैठे, तुम्हारे वीडियो में ऐड आ रहा है, क्या आ रहा है, वो आ रहा है, ठीक है ना, उसका सोल्यूशन तुम खुद से ढूंढो। 2-bit कंपैरेटर इज लॉजिक 1, तो क्या होता भाई, n1 a is whenever 2 input a is greater than a greater than b कितने कॉम्बिनेशन में ट्रू होगा, इन हाउ मेनी कॉम्बिनेशन a is greater than b, जितने कॉम्बिनेशन में a greater than b होगा, लॉजिकल आउटपुट y उतने कॉम्बिनेशन में 1 होगा, a greater than b वाला, या उतने टर्म या सोपी एक्सप्रेशन में आएंगे। 2 बिट से टोटल 16 कॉम्बिनेशन होंगे, और कुछ कॉम्बिनेशन में a ग्रेटर देन b होगा, उतने टर्म y के लॉजिकल एक्सप्रेशन में या सोपी एक्सप्रेशन में आएंगे, बाकी टर्म पीओएस एक्सप्रेशन में आएंगे, टोटल 16 में से, है ना, सब बताया था, है ना। तो व्हाट इज, कैसे करते हैं, अगर दोनों के नंबर ऑफ बिट सेम है, n बिट के हैं, तो a के जितने पॉसिबल a वैल्यूज ले रहा सबको ऐड कर दो। a 2 बिट से कितने पॉसिबल वैल्यू लेगा, 0 + 1 + 2 + 2 की पावर 2 - 1 तक वैल्यू लेगा, 0 से लेके, तो इन सबको ऐड कर दो, 0 + 1 + 2 + 3 दैट इज 6, तो आंसर इज 6, बी ऑप्शन करेक्ट। और इतने ही कॉम्बिनेशन में a लेस देन b भी होगा, उसमें भी अगर सेम नंबर ऑफ बिट्स होते हैं तो a या b के जितने टोटल पॉसिबल वैल्यूज हैं सारे ऐड कर दिया करो, बस आंसर आ जाएगा 6। और n3 क्या आएगा, a = b, तो हमें बताना था ये वाला a = b वाला क्या आ जाएगा, ये 2 की पावर n हो जाता है अगर दोनों n बिट के हैं, तो 2 की पावर 2 4, टोटल 16 कॉम्बिनेशन हो गए, कुछ कॉम्बिनेशन में a ग्रेटर देन b, कुछ कॉम्बिनेशन में a लेस देन b, कुछ कॉम्बिनेशन में a = b। इसका आंसर जल्दी से बता दो क्या होगा, व्हाट विल द आंसर ऑफ दिस क्वेश्चन, ओके, व्हाट विल बी द आंसर ऑफ दिस क्वेश्चन। बताओ क्या होगा इसका आंसर? A 16-bit triple carry adder is realized using 16 identical full adders. Identical full adders means the carry and sum delay of each full adder will be same. So read the words carefully. Identical full adders, 16 full adders are there. The carry propagation delay TC of each full adder is 12 nanosecond. Sum delay of each full adder is 15 nanosecond. Then the worst case delay of 16-bit adder will be, worst case delay is what? है ना? We add carry delay up to n-1 full adders, except the MSB bit full adder, that is A15, 0 to 15, there are 16 full adders. So the except the 16th full adder, the initial 15 full adders, in case of initial 15 full adders, we add the carry delay of each full adder. So the TC plus TC plus TC 15 times, this will be 15 TC. And in case of last full adder, what we do is we add the maximum of TC and TS of the last full adder. Okay. And in TC TS, the maximum is TS, so this is 15 TC plus TS. 15 TC is 15 into 12 plus TS is 15. So this is nothing but 15 into 13. This is 195 nanosecond. अब इसके लिए कैल्सी की जरूरत नहीं आपको पढ़नी चाहिए, है ना? 195 नैनोसेकंड, 13 into 15 आपको करने आना चाहिए फास्टली. ओके, सॉल्व दिस क्वेश्चन. Okay. This is YZ. YZ is select at the select input of every mux. बताइए जल्दी से आंसर. What will be the answer of this question? What is the answer? What is the answer for this question? Which one of the following circuit implements the Boolean function given below? So they have taken YZ at the select line. So this is a 3 variable function. So if YZ is at the select line, then definitely X will be on the input side. X can come in the form of X bar or X. So let us find out the value of I0, I1, I2 and I3. So in which terms X, Y, Z will have total 8 terms from 0 to 7. In which terms X will be in form of 0 or in form of X bar? 0, 1, 2, 3. In 0, 0, 0, 0, X will be 0 because X is MSB. 0, 0, 1, X is 0. 0, 1, 0, X is 0. 0, 1, 1, X is 0. So in term 0, 1, 2, 3, X will be in X format. And in 4, 5, 6, 7, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1, X will be in form of 1, that is in form of X. Now what you need to do is, you have to mark the terms which are there in SOP expression. M0 means 0, M1 means 1, M3 means 3, M4 means 4, M5 means 5, M6 means M6. Now if both are marked, the result is 1. If both are marked, result is 1. Only one is marked, then If it is mark corresponding to x, then it is x. If it is mark corresponding to x bar, then it is x bar. If nothing is marked, then result will be 0. So what is the answer is I0 is 1, I2 is I1 is 1, I2 is x, and I3 is x bar. Option A is correct. Option A is correct. Now this is a question of sequential circuit. Tell me the answer of this question. GATE 2013 2 marks question. Okay. The answer is A option, D, C. How you are getting D and C options, sir? ओमकार A. अमित वाइंस बेटा, आप बहुत जल्दी में कह रहे थे जल्दी जल्दी कराइए, आंसर कुछ का कुछ निकाल लो, कहां से डी आ जा रहा है भाई? अमित वाइंस बेटा, इसलिए अमित वाइंस बेटा आपको एक सलाह है, एग्जाम में क्वेश्चन जल्दी करने के मार्क्स नहीं मिलेंगे, एग्जाम में क्वेश्चन सही करने के मार्क्स मिलेंगे। तो जो लोग 3 घंटे में सोचते हैं बहुत जल्दी पेपर सॉल्व कर दें, उनके पेपर अक्सर खराब होते हैं। आप यकीन मानिए 2 से 3 मिनट सबको मिलते हैं क्वेश्चन सॉल्व करने के लिए। तो आप शुरू में रिलैक्स होके, रिलैक्स का ये मतलब कि एक ही क्वेश्चन पे 10-15 मिनट बिता दें, रिलैक्स होके काम होके आराम से एक टाइम देते हुए क्वेश्चन को सॉल्व करिए प्रॉपरली, ना कि बहुत हरी में रहिए ताकि आता हुआ क्वेश्चन, इजी क्वेश्चन गलत हो जाए। ये इजी क्वेश्चन है 1 नंबर का, इट इज अ वेरी इजी क्वेश्चन। YZ, you have to put YZ at select line and then you need to find out the value of I0, I1, I2 by this table, which can be find very very easily. In the revision session also I have covered this concept of mux, and directly we are finding out the answer. What is the problem in that? Easily. अगर आप इस तरह के क्वेश्चन गलत कर रहे हो तो यू आर lagging behind from many students who will not solve this question wrongly. Okay, करेक्ट सॉल्व करना ज्यादा जरूरी है बेटा अमित, है ना, rather than solving in hurry and getting the wrong answer. चलो इसका आंसर बता दो सब लोग, प्लीज टेल मी द आंसर ऑफ दिस क्वेश्चन. What is the answer of this question? बताइए आंसर जल्दी से इसका. What is the answer of this question? So you need to find out the frequency output at Q. You need to generate the pattern, and for that you need to find out the mod number of this counter. So how to find out the mod number of this counter? Firstly, write down the characteristic equation of this T flip-flop, because characteristic equation always tell you what is the next state if the flip-flop being triggered. So T XOR Qn. Now let us find out what is this X value is. This is Q is coming here and here, and this Q bar is coming here and here. So Q XOR Q bar will be 1. Q XOR Q bar will be 0, because both are different. Because Q is here and Q bar is also here. Q is here and Q bar is also here. So Q XOR Q bar is 0 because both are different. Q1 XOR Q1 bar is 1. Now, in case of NAND, if input is, one of the input is 0, then definitely it will be 1. So, T input is always equal to 1, irrespective of the value of Q and Q bar. Because whatever the value of Q and Q bar, this XOR will produce 1, this XNOR will produce 0, and this NAND gate will produce 1. So, what will be the 1 XOR Qn? And this will come out to be Qn bar. Toggle mode of operation. If a flip-flop operates in toggle mode of operation, where next state is complement of present output state, then it is equivalent to mod 2 counter. And if it is mod 2 counter, then output frequency FQ will be input clock frequency divided by mod number 2. The input clock frequency is given as 1 kilohertz, then output will be 1 kilohertz by 2, that is 0.5 kilohertz. The answer is 0.5 kilohertz. B option is correct. B option is correct. Very good. B option is correct. Okay. This question is not very tough. This is an easy question, but it looks like a tough question. Okay. And this is now this question. Solve this question. What is the answer of this question? The above synchronous sequential circuit built using JK flip-flop is initialized with Q2, Q1, Q0, 0, 0. So initially all the outputs of the flip-flop, present outputs are being 0, 0. The state sequence for this circuit for the next 3 clock cycle. So you need to find out the output for next 3 clock cycle. But if you look at the output state, after 0, 0, the next state will be 0, 0, 1 given here, 1, 1 given here, 1, 0, 0, 1, 0, 0. So if after 0, 0, 0, my first state will be 0, 0, 1, then I will not solve further because this answer only will be correct. If I find out the 1, 1, 1 after 0, 0, then this answer will be correct. I will not find out the further state. But if it comes out to be 1, 0, 0, then either answer this or this can be correct. Now I'll find out the next state after 1, 0, 0. If it comes out to be 1, 1, 0, this answer will be correct. If it is 0, 1, 1, then this answer will be correct. So I need not to find out all the 3 states actually. All the next possible 3 states. Either I need to find out one next state after 0, 0, 0 or 2 states after 0, 0, 0. Then I can find out the answer very easily from the given options. So always look for the options very correctly. Your observation skill should be good in examination. What are the options given? You have to look at the options very carefully. Okay, solve this question. I have given you the hint. Okay. बताइए आंसर. So write down the clock is same for every flip flop. So it is a synchronous counter question. Now the write down Q2n plus 1, which is nothing but J2 Q2 bar plus K2 bar Q2. J2 is J2 is nothing but Q1 bar. So J2 is Q1 bar, J2 Q2 bar, Q2 bar can present plus K2 bar. K2 is nothing but Q naught. So K2 bar is Q naught bar into K2 bar Q2. J2 Q2 bar plus K2 bar Q2. So this is characteristic equation. I cannot solve it further. So the next state of the Q2 is based on this characteristic equation. If I know the value of present output state of Q1, Q2, Q0, Q2, then I can find out the J2. What is the Q1n plus 1? Q1n plus 1. It is basically J1 Q1 bar plus K1 bar Q1. J1 is Q2n. Q2n. J1 Q1 bar plus K1 bar. K1 bar is Q2n basically. क्योंकि Q2 bar is Q2n है ना. K2 bar Q1. K2 bar K1 bar Q1 and K1 bar Q2 bar is Q2 and K1 bar Q1. Now I can take Q2n common. Q1 bar n plus Qn is 0. So what is the next state of Q1 is nothing but the present output state of Q2 will be Q1n. And what is Q0 n plus 1? Q0 n plus 1 is again J0 Q0 bar. J0 is Q1n. Q1n Q0 bar n plus K0 bar. K0 is Q0 bar. Q0 bar is Q0 n. K bar Q0 n. K0 bar Q0 n. And K0 bar is Q0 bar and bar is Q0 n into Q0 n. Now I can use distribution theorem here, Q1 n plus Q0 n. Because this is Q0 n into Q0 n. This is Q0 n. Q0 n, if I'll distribute Q0 plus Q0 bar n, Q0 n plus Q1 n. Q0 plus Q0 bar n is 1 and then I'll remain with this. Now let us write down the state. This is Q2, this is Q1, this is Q0. This is the present output Q2n, Q1n, Q0 n. If first trigger will be there, then all the flip-flops, as soon as trigger will appear, all the flip-flops will get triggered and change the state from the present state to next state. The next state of Q2 is, this is Q1n, this is Q2n, Q1n, Q0 n. Put the value of this and get the answer. है ना? So Q1 0 bar is 1, 0 bar is 1. So 1 into 1 is 1 and 1 plus anything is going to be 1. So I will not solve further. So Q2, the next state of Q2 will be 1 from this equation, where Q2n, Q1n, Q0 n is 0, 0, 0. Now what is the next state of Q1n plus 1? The present state of Q2n will be the next state of Q1. Present state of Q2n is 0. Q2n is 0, Q1n is 0, Q0. So this 0 becomes the next state of what? Q1. And what is the Q0 n? N plus 1, Q0 n plus 1 is here. It is Q1 n plus Q0 n. Q1 n is 0, Q0 n is 0. 0 plus 0 is 0. So the next state of, after applying first clock with the initial state is 0, 0. What is, I am getting the first state as 1, 0, 0. So these two options are wrong. Whether this option is correct or this option is correct. Now find out the next state, second. Second trigger appear. When second trigger appear, the Q2n is 1, Q1n is 0, Q0n is 0. This is the present state and whatever I will be getting will be the next state. So what is the value of Q2n plus 1? Q2n plus 1. Q1 is 0, Q2n is 1 है ना. So 0 bar is 1, 1 bar is 0. So 1 into 0, 0 आ गया. Q0 bar, 0 bar is 1, Q0 n is 0, 0 bar is 1 into Q2n. Q2n is 1, 1 into 1 is 1. So I'll be getting 0 plus 1, 1. So the Q2n will be, next state of Q2n will be 1. I'll be not solving further, answer is C. Because look at here, after 1, 1, 0, the next state here is 1, 1, 0. Next state here is 0, 1, 1, where Q2 is 0. But Q2 is coming out to be 1. So I'll not solve further. This option is definitely correct. So just finding out 1, 0, 0 and this one, I'll be able to reach the answer. So you have to look the options very carefully. You have to look the options very carefully in examination. Okay. Clear? So you need not to solve further. You need not to find out all the possible answers. Okay. Try to find out the answer of this question. Try to find out the answer of this question. What is the answer of this question? D is the right answer. Okay. आवाज आ रही है? आवाज आ रही है? Okay. So you know how to write down the next state of Johnson counter. How to write down the next state of Johnson counter? Initial n minus 1 bit will be shifted by right position by 1 bit. So initial 3 zeros n minus 1 bits will be shifted by 1 bit right, and complement of the last bit 0 will be here. So after 0 you will be getting 8, and only one option is containing the next state of 0. So all these three options are wrong. D is the correct. So you have to use the options very carefully in case of MCQ questions. You need to observe the options very carefully. So in many cases, you need not to solve the question completely, rather than by eliminating the options, you can find out the answer very easily. And this will save your time. This will save your time. Okay. Let us move to the next question. Let's move to the next question. Okay. Let's move to the next question. What is the answer of this question? 2-3 questions are remaining, then we'll close this session and we'll meet at 7 p.m. That session will be a bigger session, means in the time length that will be a session of at least 3 hours, 2.5 to 3 hours, where we will be solving some important questions. And firstly, I'll take the questions related to number system, because I want to I want to cover the number system that was there, that was left in the yesterday's revision class. So we'll cover that first, okay, and then we'll move further. Okay. And if any other important concept I'll feel that is important, then I'll cover that also, okay, in that session. Okay. What is the answer of this question? आवाज अब तो आ रही होगी भाई, चैट डिले चल रहा है ना, आवाज अब तो आ ही रही होगी भैया, अब तो आ ही रही होगी पक्का। A sequence detector is designed to detect precisely 3 discal inputs with overlapping sequence detectable for the sequence 101 and input data to be this. So whenever sequence will be detected, output will be 1, and whenever sequence will not be detected, output will be 0. And when sequence will be detected? When the last bit of sequence 101 will be detected. Now find out when this input bit 1 will be appear, whether sequence is detected? No sir. So output will be 0. After 1 you will be getting 1. Sequence is detected? No sir. So output will be 0. 1 1 0 sequence is detected? No sir. So output will be 0. Now 1 0 1 here sequence is detected. 1 0 1. So as soon after 1 after 0 after that you will, as soon as you will find out this one 101 sequence is detected. So as soon as you will find out this one, your sequence is detected, so output will be 1. Okay. So from the option, all the options are I think wrong, are misprinted. So I'm generating the options, correct option, and then we'll see. Overlapping is allowed. Now after 1 this 0 is detected, whether sequence is detected? No sir. So output will be 0. Okay. This is the pattern. So you will be getting 0. After this 1 0 0, whether sequence is detected? No sir. After this 0 0 1, sequence is detected? No sir. After this 1 1, whether sequence is detected? No sir. 0. You can take 3 bits 0 1 1, no sequence is detected. After this 1 1 0, sequence is detected because 3 bit sequence is there. 1 1 0, no sir. After taking this 1 1 0 1, sequence is detected. So as soon as this 1 will appear, you will get the sequence. So there will be 1. Okay. So there is misprinting I think. Now overlapping is allowed. Overlapping is allowed. So after 1 this is getting 0. After you can take 0 1 0, sequence is detected 3 bit? No sir. 0 1 0. So output will be what? Output will be 0. You can always take 3 bits. So by adding next bit you can take 2 previous bits, so that 3 bit sequence, and you can compare with 101. 0 1 0 sequence is detected? No sir. Output is 0. Now 1 0 1 sequence is detected? Yes sir. 1 0 1 overlapping is allowed. You are overlapping this one, you are using this one of detected sequence. Overlapping is allowed here. You can use this one of detected sequence. So here you are always you are getting the sequence. Okay. Now 0 1 1 sequence is detected? No sir. Now 1 1 0 sequence is detected? No sir. So this is the output bit sequence, and I think no option is containing this. There may be the misprinting, I guess. There may be the misprinting. Okay. There may be the misprinting. Okay. Here 1 0 0 is there, 1 0 is there. Okay. So this option is resembling. So this B option is very closely resembling, because if I'll take this one out, take this one out and make this 0, and I'll take this 0 0 and I'll take this as 1, then this option will be correct. Okay. 0 0 0 1, then triple. Okay. 3 4 5 6 7 8 9 10 11 12 13 14. Here the answer is 4 3 3 2. There should be 15 bits. How many bits are there? That much. There should be. This part is matching. So that's why I am guessing that there will be some zeros in between. Okay. There will be some zeros in between. 0 and 0. 5 zeros will be there. 1 2 3 4 5 zeros, and then 1 0 1 0 0. So then this B option will be correct. Okay. Make it correct. Okay. Make it correct. So there will be misprinting or some whatever. There is some, I think this is probably the last question. Okay. What is the answer of this question? 2024 question, 1 mark question. Try to solve this question. बहुत बढ़िया श्रेडेड बेटा। जैसा भी पेपर आएगा, अगर डिजिटल इलेक्ट्रॉनिक्स अच्छे से पढ़े हो तो मुझे नहीं लगता डिजिटल इलेक्ट्रॉनिक्स में कोई गलती होगी, और बहुत आसानी से आप लोग क्वेश्चन सॉल्व करके आ सकते हो। बस आपको लैंग्वेज थोड़ा ध्यान से पढ़ना होगा एग्जाम में, और लैंग्वेज को समझ के अपने कॉन्सेप्ट को यूटिलाइज करना होगा ध्यान से। कई बार आप प्रेशर में लैंग्वेज को नहीं समझते हो, बाकी चीजों को नहीं समझते हो, तो गलत हो जाता है। बताइए इसका आंसर क्या होगा? स्क्वायर वेव फॉर्म ऑफ 100 मेगाहर्ट्ज, स्क्वायर वेव फॉर्म ऑफ फ्रीक्वेंसी 50 मेगाहर्ट्ज। Output is generated at every bit. Okay, output is not like I'll not be generating output, है ना? You output is a connection. Output is a wire. Output is you are taking from, you are making some circuit, है ना, for generating the output. So output will be generating at every input bit. At every input bit, it will not be like output will be generated only first bit of the sequence, or output will be generated only at the end of the sequence. It is not like that, beta. We will design this circuit. Output is a circuit. Whenever input will change, output will change. Output will either be 0 or 1 according to the designing of the circuit. So output will be generated at every input bit. Okay, so either it will be 0 or 1. It's not like it will be generated after completing 3 bits, it will be generated after completing 4 bits. It's not like that. Okay, now what is the answer of this question? This is the last question for today's class. Okay, so what is there? This mux is having delay of 10 nanosecond, and this NOT gate has 0 delay. Okay, so at the output, yes is permanently at 1. If yes is permanently at 1, that means you are selecting I1 and sending it to the output. You are selecting I1 and sending it to the output. Let us start Y. We need to find out the waveform at Y, and then we can find out whether any that waveform is a periodic waveform. Then we have the frequency. If output is constant at 0, we'll get the 0. If output is constant at 1, we'll get the 1. Okay, now I'm starting at t is equal to 0, y with 0. So as soon as y is 0, what is happening? This 0 will come here, this I naught will become 0, this I naught will become 0, and at the same time I1 will become 1, because NOT gate has a 0 delay. Suppose at t is equal to 0, this output y is 0, then at t is equal to 0, this input is 0, this input is 1, because NOT gate has a 0 delay. Now you have taken s is equal to 1, then this mux will transfer the I1 information to the output, but this I1 will be transferred after 10 nanosecond, because mux has a delay of 10 nanosecond. So till 10 nanosecond, y will remain its previous output value, that is 0. Currently the output is 0, and this 1 will be transferred after 10 nanosecond. So y will remain at 0 for next 10 nanosecond. So next 10 nanosecond output will be at 0. And after 10 nanosecond, as soon as you'll get 1 from here, y become 1. As soon as y become 1, now this will come in feedback, and at 10th nanosecond, this will become 1 and this will become 0. Now this 0 will be transferred at the output after 10 nanosecond. Till 10 nanosecond, this y will remain its previous value, which is 1. So for next 10 nanosecond, y will be 1. And after 10 nanosecond, as soon as 0 will be transferred, y will be 0. And now this y is 0, then again here it will be 0 and here it will be 1. Now this one will be transferred after 10 nanosecond. Till this one will not be transferred, y will remain its previous value, that is 0. So for next 10 nanosecond, y will be 0. And then again the same process will happen. Y will go 1, 0, 1, 0, 1. So this is a square waveform. From this to this, it is repeating. 10 nanosecond 0, 10 nanosecond 1. Then again repeating 10 nanosecond 0, 10 nanosecond 1. So the t of time is 10 nanosecond, t on time is 10 nanosecond. The total time period t is 20 nanosecond. Then frequency f is 1 upon 20 nanosecond. So 1 upon 20 into 10 to the power minus 9 second, then it is hertz. This will be 10 to the power 9 upon 2 hertz. Now 10 to the power 6 will convert this hertz into megahertz. Then it will remain with 10 to the power 3, that is 1000 divided by 2 megahertz. Okay, 20 megahertz. This is 50 megahertz. This is 20. So we will get a square waveform of 50 megahertz at the output B. So you need to find out the waveform. Okay. Clear? Please, everyone, respond. Clear? Okay. 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 क्रैश कोर्स पे बेटा जो भी चीजें पढ़ लिए, मतलब दैट इज नॉट कंप्लीटली सफिशिएंट, बट जो भी क्रैश कोर्स में टॉपिक कवर्ड है उनसे क्वेश्चन आएगा तो आप कर लोगे 100%, अगर क्रैश कोर्स आपने अच्छे से किया है। अब अगर भाई क्रैश कोर्स में सिक्वेंशियल में नहीं करा पाया हूं, पता नहीं कराया कि नहीं, आई डोंट रिमेंबर, तो अगर सिक्वेंशियल का क्वेश्चन आएगा तो हाउ दैट विल बी सफिशिएंट ना। So that is sufficient whatever the topic are covered. In that sense that is sufficient कि अगर उन टॉपिक से क्वेश्चन आता है you will be definitely be able to solve it. Okay, for sure, 100% sure. Okay, so okay बच्चों, तो हम लोग 7 PM पे मिलेंगे गेट वाला ECE चैनल पे, और जहां पे हमारी टीम ने भी जो क्वेश्चन फ्रेम्ड करके दिए हैं वो करेंगे, और कुछ क्वेश्चन मैं लाइव वहीं पे फ्रेम करूंगा, जैसे कल रिवीजन में किया था। तो आज तो केवल क्वेश्चन डिस्कशन करना है, तो मैं बहुत ही अच्छे अच्छे क्वेश्चन फ्रेम करके आपको कराने वाला हूं उसी टाइम पे, जैसा आपका रिस्पांस रहेगा। तो जैसे कल की क्लास में आए थे पूरी बड़ी संख्या में और मस्त तरीके से हम लोगों ने एंजॉय किया था, वैसे ही आज की 7 PM की क्लास में आना, हम क्वेश्चन डिस्कशन करेंगे। तो जितने कॉन्सेप्ट तुमने रिवाइज किए हैं वो क्वेश्चन डिस्कशन से और क्लैरिटी मिल जाएगी। पहले नंबर सिस्टम क्वेश्चन के थ्रू कवर कर लेंगे, मैं कई चीजें रिकॉल करा दूंगा, वहां कुछ क्वेश्चन मैं उसी टाइम पे फ्रेम करके करवा दूंगा, कुछ जो टीम ने बनाए होंगे वो करवा दूंगा, फिर बाकी टॉपिक जो ऑलरेडी हम कल रिवीजन में कवर किए थे उन पे भी क्वेश्चन डिस्कशन करेंगे। तो अटेंडेंस एकदम फुल रहनी चाहिए 7 PM की क्लास में, मस्त तरीके से हम लोग एंजॉय करेंगे और प्रैक्टिस करेंगे, है ना। ठीक है, क्लियर ना बेटा। शाम में 7 बजे सिंजो मिलना, वहां पे क्वेश्चन डिस्कशन हम लोग कर लेंगे, ठीक है ना। ठीक है, चलो। एक फुल एडर का कराया तो था बेटा श्रेडेड, फुल एडर का ही तो कराया था, जो वर्स्ट केस डिले था वो फुल एडर का ही तो था, फुल एडर का ही तो था, ठीक है ना। चलो, सो मिलते हैं 7 PM पे with महाअभ्यास, where we are going to discuss some beautiful questions. Some basic question will also be there, some moderate question will also be there, and some beautiful questions will be there which will test your conceptual knowledge, your insight knowledge of the subject, है ना। And through those questions we will be completing this revision completely thoroughly, and that is going to help you in a big way in upcoming GATE 2025 examination, है ना। ठीक है ना। हाँ, वो तो शुरू में ही बता देंगे बेटा, आज भी तो क्वेश्चन किए नंबर सिस्टम के PYQs में, ठीक है ना। चलो, थैंक यू सो मच एवरीवन, मिलते हैं 7 PM पे गेट वाला ECE चैनल पे, और मस्त तरीके से महाअभ्यास को कवर करेंगे डिजिटल इलेक्ट्रॉनिक्स का। थैंक यू सो मच, थैंक्स अ लॉट।